Hello all. In this video we will see revised GATE syllabus for Aerospace Engineering Department. Before going to the syllabus, we will have some important points on GATE examination 2021. The organizing institution for GATE 2021 is IIT Bombay. So September month onwards you can fill the application online for the GATE 2021. In this year, they introduced new syllabus as well as the new eligibility criteria and new papers also for science and humanities streams. So we will have a look at aerospace engineering syllabus for GATE 2021. Important note for candidates. In each of the following subjects, the topics have been divided into two categories: core topics and special topics. The corresponding section of the question paper will be contain 90% of the questions on core topics and the remaining 10% on special topics. So we will go through the syllabus now. First session, engineering mathematics. So engineering mathematics is very important for all the engineering streams. So we will see first core topics, then we will move to the special topics for engineering mathematics. Linear algebra. In the linear algebra section, we will have the different types of linear algebra problems for the GATE examination, such as vector algebra, matrix algebra, systems of linear equations, rank of a matrix, eigenvalues and eigenvectors. Then calculus. In this session, we will see the following syllabus for the calculus streams: function of a single variable, limits, continuity and differentiability, mean value theorem, chain rule, partial derivatives, maxima and minima, gradient, divergence and curl, directional derivatives, integration, line, surface and volume integrals, theorems of Stokes, Gauss and Green. The next section will be differential equations. First order linear and nonlinear differential equations, higher order linear ODEs with constant coefficients. Here ODE is nothing but ordinary differential equations, partial differential equations and separation of variable methods. So we will move to the special topics for engineering mathematics session. 4-year series, Laplace transforms, numerical methods for linear and nonlinear algebraic equations, numerical integration and differentiation, complex analysis, probability and statistics. The next section of the GATE aerospace engineering paper is flight mechanics. First we will see the course topics: basics, atmosphere, properties, standard atmosphere, classification of aircraft, airplane, fixed wing aircraft, configuration and various parts, pressure, altitude, equivalent, calibrated, indicated airspeeds, primary flight instruments, altimeter, ASI, VSI, turn back indicator, angle of attack, side slip, roll, pitch and yaw control, aerodynamic forces and moments. Then airplane performance, drag polar, takeoff and landing, steady climb and descent, absolute and service ceiling, range and endurance, load factor, turning flight, VN diagram, winds, head, tail and crosswinds, static stability, stability and control derivatives, longitudinal stick fixed and free stability, horizontal tail position and size, directional stability, vertical tail position and size, lateral stability, wing diagonal, sweep and position, hinge movements, stick forces. Now we'll see the special topics as a section: flight mechanics, dynamic stability, Euler angles, equations of motion, decoupling of longitudinal and lateral directional dynamics, longitudinal modes, lateral directional modes. Section 3, space dynamics, core topics: central force motion, determination of trajectory and orbital period in simple cases, Kepler's laws, escape velocity. There is no special topic under space dynamics section. Then we'll move to the aerodynamics session. Core topics: basic fluid mechanics, conservation laws, mass, momentum and energy, integral and differential form, dimensional analysis and dynamic similarity, potential flow theory, sources, sinks, doublets, line vortex and the superposition, elementary ideas of viscous flows including boundary layers, airfoils and wings, airfoil nomenclature, aerodynamic coefficients, lift, drag and moment, Kutta-Zewski theorem, thin airfoil theory, Kutta condition, starting vortex, finite wing theory, induced drag, frontal lift line theory, critical and drag divergence Mach number, compressible flows, basic concepts of compressibility, one-dimensional compressible flows, isentropic flows, Fana flow, Rayleigh flow, normal and oblique shocks, Prandtl-Meyer flow, flow through nozzles and diffusers. Special topics under aerodynamics is wind tunnel testing, measurement and visualization techniques, shock boundary layer interactions. Next section is structures. Core topic: strength of material, stress and strain, three-dimensional transformations, Mohs circle, principal stresses, three-dimensional Hooke's law, plane stress and strain, failure theories, maximum stress, Traska and von Mises, strain energy, Castigliono's principles, statically determinate and indeterminate stresses and beams, elastic flexural buckling of columns, flight vehicle structures, characteristics of aircraft structures and materials, torsion, bending and shear of thin wall sections, loads on aircraft, structural dynamics, free and forced vibration of undamped and damped SDOF systems, free vibrations of undamped second degree of freedom systems, DOF systems. Special topics: vibration of beams, theory of elasticity, equilibrium and compactability equations, Airy's stress function, propulsion. Core topics: basics, thermodynamics, boundary layers, heat transfer, combustion and thermochemistry, aerothermodynamics of aircraft engines, thrust, efficiency, range, Brayton cycle, engine performance, ramjet, turbojet, turbofan, turboprop and turboshaft engines, afterburners, turbo machinery, axial compressors, angular momentum, work and compression, characteristic performance of a single axial compressor stage, efficiency of the compressor and degree of reaction, multi-staging, centrifugal compressor, stage dynamics, inducer, impeller and diffuser, axial turbines, stage performance, rockets, thrust equation and specific impulse, rocket performance, multi-staging, chemical rockets, performance of solid and liquid propellant rockets. Special topics: aerothermodynamics of non-rotating propulsion components such as intakes, combustor and nozzle, turbine blade cooling, compressor turbine matching, surge and stall. So those who are planning to apply for aerospace engineering department gate examination 2021, please follow this syllabus and share the syllabus with your friends to get the beneficial. Thank you.